I don't know how I skipped that slide while doing this. I must have pressed the space bar by mistake. I'm sorry about that. What are you going to do? So that was one example. Let's do another one. So this one's similar, except now you have absolute value all alone on one side already. Okay, that makes it a little bit easier. So from here, we're going to get two equations. This is one equation. The other one is here. Basically, what you have is 2 over 3 times x minus 7 in absolute value is 4. And 2 over 3 times x minus 7 in absolute, excuse me, from the absolute value, you get two equations. You have 2 over 3 times x minus 7 is 4. And here we have 2 over 3 times x minus 7 is negative 4. So those two equations we have to solve. Okay, we just want to get x all alone. So we have 2 over 3 times x, right? Minus 7 equals 4. Again, we want to get x all alone. So we add 7 to both sides, right? That gets the 7 out of there. We have 2 over 3 times x equals 11. Okay? And I just brought this closer. But we don't want to leave this as 2 over 3 times x. We want x all alone. So what do? We divide. We divide both sides by 2/3. These cancel. And we're left with 11 divided by 2/3. That's not really the best way to leave it, so let's see if we can make it look better. What do? Well, if you divide by a fraction, right, we have 11 divided by 2/3. This is the same, of course, as this, division symbol. And then, when you divide by a fraction, you multiply by its reciprocal. In other words, you take the fraction, you turn it upside down, so the 3 goes on top, 2 goes on the bottom, and you multiply. And this is what we get, 11 times 3 over 2. And now what is this equal to? Well, 11 is an integer. You just multiply that by the numerator. So we get 11 times 3 over 2, which is 33 over 2. So that's one answer. But now for the other equation, right? This was when 2 over 3 times x minus 7 was 4. For the other equation, instead, we have it equal to negative 4. But it's actually the same steps. In other words, well, it's the same idea, I should say. Because you want x to be all alone. So we add 7 to both sides, as you can see. Right? We add 7 to both sides. We get 2 over 3 times x is 3. 2 over 3 times x is 3. Then, right, we added 7 to both sides. That's how we got that. Then we bring the 2 over 3 times x closer. Okay, so what do we do now? Well, it's just like before. We don't want to leave this as 2 over 3 times x. We want x. So what do? What do we do? Excuse me. We divide by 2/3. And when you divide by 2/3, these cancel. You get x all alone. on the left side. But on the right side, we have 3 divided by 2/3. And it's just like before, right? We have 3 divided by a fraction. So what do we do here? Well, this is 3 divided by a fraction. We multiply by the reciprocal. In other words, we take this fraction, turn it upside down, right? Take its reciprocal and multiply. We get 3 times 3 over 2, which is 9 over 2. That's our second solution. Are there any questions on this? Sorry for yawning. Well, we also had absolute value inequality. Let me just say this also. Well, there was something I wanted to say about it, but let's go through it first. You have absolute value, right? Less than 9. So we must solve this compound inequality. You know, from an inequality here, we get 2 inequalities to solve. From here, we get this. From here, we get this. We have -9 less than 3x plus 4 less than 9, as you can see. Right? So we have this compound inequality. 2 inequalities at once we need to solve. And again, what do? You get x all alone in the middle. You get x all alone in the middle. Okay, how do we do that? Well, let's subtract 4 from both sides. We get 3x less than 5 greater than -13. From here, we have this. We want x all alone, not 3x, so we divide by 3. And that gives us x in the middle greater than -13 over 3, less than 5/3. Notice here we have strict inequality, so our solution set will be an interval, but we're going to have parentheses. We're not going to have square brackets, as you can see. So -13 over 3, 5 over 3, as you can see. Okay, this is what I wanted to say. I've seen people, what they do is they would have this compound inequality, but then they would also solve inequalities like 3x plus 4 greater than 0, 3x plus 4 less than 0. You only have to solve these 2 inequalities like I'm doing. You know, don't do more work than necessary. Okay? You know, you don't want to solve 3x plus 4 greater than 0 less than 9 and greater than -9 less than 0. You know, that's doing more work than necessary. Just do this, is what I'm saying. Okay. Any questions on this? All right, here's another example. So we have absolute value of -6x plus 1 less than or equal to 11. From here, we get this compound inequality. -6x plus 1 less than or equal to 11, greater than or equal to -11. We want x all alone, right? So what do? We divide by, we don't divide yet. We want to get the 1 out of here, so let's subtract, like so. And we get -6x less than or equal to 10, greater than or equal to -12. Now notice here, we're going to be dividing by -6. If you're multiplying or dividing by a negative. If you're multiplying or dividing by a negative, remember, you flip the inequality. That's what I'm doing. Okay? So we divide everything by -6. We get x in the middle. This turns around, and we get 10 over -6. Okay? Okay? We divide this by -6 to get 2, but this inequality turns around as well. Now here I'm reading right to left, but here basically I'm rewriting the above in an equivalent way, right? 10 over -6 is less than or equal to x, less than or equal to 2. And here we have -10 over 6, less than or equal to x, less than or equal to 2. So our solution set is an interval from -10 over 6 to 2. We have square brackets though, because these inequalities are not strict inequalities. So we have -10 over 6 to 2. Okay, and again, you only turn the inequality around when you multiply or divide by a negative. Here we subtracted, but we did not change the inequalities. Okay. Are there any questions on this? Okay, so I think we really, I mean, I did have something from the quadratic formula, but we really have to stop here because we're low on time. All right, so again, I have office hours tomorrow. If you need to reach me for other stuff, you can always email me, and I'm more than willing to meet through Blackboard if necessary. Okay? All right, so let me stop here.